This lesson is going to talk about using graphs to relate to quantities. This is kind of one of my favorite things in Algebra 1 that we get to do. I think it's fun to show relationships using the graphs. Variables on a graph. A graph shows relationships between two variables. These variables are used to label the axes of the graph. For today, we're just going to use mostly the first quadrant. Eventually, when we start graphing different functions and equations, we're going to end up using the XY coordinate plane. But for today, we're just going to use the first quadrant of that coordinate plane. This says the graph below shows the amount of gasoline in Jamie's car after she fills up her tank. What are the variables, and describe how they are related at various points on the graph. So the variables, if you read the labels of the axes, you'll see that the variables are time on the horizontal axis and gas in gallons on the vertical axis. Time is measured in days here. So if you look at this graph, the overall trend, meaning if you just look not at the individual sections of this graph, but if you just look overall, as the time increases, the gas in the car is decreasing. So as you go from left to right on the horizontal axis, time axis, you'll notice that the gallons of gas in the car is going down. So if you look at the actual graph and the actual line of the graph, you'll notice that there are three sections right here where it looks like she really didn't use very much gas, if any, because it's almost horizontal, if not horizontal at those points. If you look right here at this section, she used a lot of gas in a short amount of time. So maybe she had to travel a lot that day, maybe she went on a road trip over the weekend, something like that. But she used a whole lot of gas in a short amount of time compared to the other days represented on this graph. So those are kind of the high points, I would say, of this graph. Everything else, the trend is down, but it's not like sharply down, like the point that I just pointed, the part that I just pointed out on the graph, sorry. And then I said the more Jamie drives, the faster the gas decreases. The less she drives, it decreases at a slower rate or not at all, depending on if those points are actually horizontal or not. The next example says the table shows the total number of customers at a car wash after 1, 2, 3, and 4 days of its grand opening. Which graph could represent the data shown in the table? So we have some points plotted in 4 different coordinate planes, and we need to match the table that they've provided with the graph that it could go with. So if you just look, on the first day, the total customers was 61, so not very many people are going on opening day. On the second day, it almost doubles, or it does double, it over doubles, right? It goes from 61 on the first day to 125 on the second day, and it continues to increase on the third day, where it has 177, and then on the fourth day, if you notice, it has 242. So overall, the trend of the table would be that the more days that the car wash is open, the more customers it has. The only two graphs that show an increase over time would be A and B. C and D are showing a decrease in customers over time. So C and D are eliminated as possible choices. A and B are both showing an increase in customers, but which one is showing the table represented better would be A, because it shows the relationship where from the first day to the second day it increases sharply. From the second day to the third day it still increases, but not as dramatically. And then from the third day to the fourth day, again, it has a dramatic increase. The next example, or the last example, says when Malcolm jogs on the treadmill, he gradually increases his speed until he reaches a certain level. Then he jogs at this level for several minutes. Then he slows to a stop and stretches. After this, he increases his speed at a slightly lower than before and jogs at this speed for a short while before slowing to a stop again. What is a possible sketch of a graph that shows Malcolm's jogging speed during his workout? And it asks us to label each section. So I'm going to go ahead and have my axes. Speed is going to be my vertical axis, and then time and minutes kind of got cut off at the bottom there, but that's what it says is going to be my horizontal axis. The line that I've graphed looks like this, or the graph that I've sketched looks like this. It says that he first gradually increases his speed, so that's the part that's increasing. The part that is staying horizontal is a constant speed, or his jog. Then it says he decreases his speed. Stops to stretch would be the part where the graph is actually on the horizontal axis. It says then he increases speed, but to a slightly lower than before jog. So he's increasing his speed, but not as quick as he was in his first jogging part. And then he has a constant speed of a jog. And then he decreases his speed to a stop. So that's why my graph looks like that. I've labeled each part, showing the scenario that they left in the example.